Okay, so now I want to talk about evaluating some different kinds of functions. So the function that we have here to start with is an absolute value function. So it's the same as the function that's graphed here to the right. F of x equals 2 times the absolute value of x. So remember that the absolute value means that we're not using any negative numbers. We're always using the positive value or the distance away from 0. We're not considering anything negative. So the absolute value of 1 is 1, the absolute value of 2 is 2, but the absolute value of negative 1 is 1, and the absolute value of negative 2 is 2. So anyway, we are trying to evaluate this function. So let's say that our input is negative 3. So remember that input is x, so we're going to go over to negative 3 on the x and see what our output is. So it looks to me like we're going to be right here. So let's figure out what that is on the y-axis, because the y-axis represents the output. So 1, 2, 3, 4, 5, 6. So we are at the point 3, 6. Sorry, that's negative 3, 6, which means that whenever our input is negative 3, our output is 6. Okay, so that's what it looks like on a graph. Let's go back to the function. So if we plug in a negative 3 here for x, so we're gonna, wherever I see an x, I'm just gonna put a negative 3. So I'm gonna have 2 times absolute value of negative 3. Now remember that the absolute value of negative 3 is just the positive part of that number. So it's just gonna be 3. So this just changes into 2 times 3. So whenever you take something out of the absolute value, you can replace those bars with parentheses. So we have 2 times 3, which is 6, which is just what I had here before. Okay, so let's try a different kind of function now. Let's try a rational function. So a rational function is a function that has a ratio in it, or another way of saying that is a function that has a fraction in it. So for example, let's do f of x equals x over 3 plus x. So this is a rational function. So let's go ahead and evaluate this function when x is negative 1. So if we have a negative 1 for our x, we want to evaluate when x is negative 1, that means that we're going to plug in a negative 1 anywhere we see an x. So anywhere I see an x here, I'm going to write negative 1 instead. So I have negative 1 over 3 plus negative 1. So 3 plus negative 1 is 2. So I have negative 1 over 2, which is negative a half. And that is my answer. So this is the output when x is negative 1. Let's try one more example. This time I'm going to try a radical function. So a function that involves a radical expression is one that has a square root or a cubed root or any other kind of root involved. So I'm going to take f of x equals negative the square root of x squared plus 6. So this is my function. So I'm going to try evaluating this when x is 4. So when x is 4, I'm going to plug in or put in a 4 anywhere I see an x. So I have negative the square root of 4 squared plus 6. So 4 squared is 16 plus 6 is 22. So I'm getting negative the square root of 22. Now the square root of 22 can't be simplified any further, so this is a fine place to leave your answer. And that is how we evaluate some different kinds of functions.